Basic trigonometric identities. Consider the unit circle below. We'll take a point here, and we know the radius is 1, that's why it's a unit circle. And we're going to, in the usual way, drop a vertical here to form a right-angled triangle. And we'll call this angle here theta. The length of this side would be cos theta. Perhaps I should explain that a little further. If we have, let's call this side x, then we know that cos theta is equal to x over 1, and therefore x is equal to cos theta. So the length of that side is cos theta. And then in the same way, the length of this side is sine theta. The coordinates of this point, therefore, are cos theta, sine theta. Using Pythagoras' theorem in this right-angled triangle, we get cos squared theta plus sine squared theta is identical to 1. Now, more often than not, you'll see an equal sign in here, but strictly speaking, that's an identity because it's true for any angle. It's not an equation which you could perhaps solve for a particular value of theta. This is an identity because it's true for every single value of theta. It is worth noting that when we're here, cos theta, sine theta, but note the angle here straight along the x-axis is 0. This point also has coordinates 1, 0. So it follows that the cos of 0 degrees is equal to 1, and the sine of 0 degrees is equal to 0. You can check those on your calculator, but it should be clear why that's true now. So let's look at some other standard angles. I'm just going to clear that writing in the bottom there. So if we were at this point here, which we know has coordinates 0, 1, and then think about the fact that this is cos theta, sine theta, the angle here would be 90 degrees. So that tells me that cos of 90 degrees is equal to 0, and the sine of 90 degrees is equal to 1. Now let's come to this point just here. So we can see that the angle here is 180 degrees. So this point here is cos 180 and sine 180, but it's also clearly negative 1, 0. So the cosine of 180 degrees is negative 1, and the sine of 180 degrees is equal to 0. And the final one we'll look at here is straight down, which I didn't draw very well, so let's draw it straight down this line to here. So we're looking at 270 degrees. Clearly this point is the point 0, negative 1. But from all we've discussed, it's also cos 270 and sine 270. So that gives me that the cosine of 270 degrees is equal to 0, and the sine of 270 degrees is equal to negative 1. Okay, so I've just tidied all of that up. And from all of this, it should be clear that the cosine of theta, the smallest value it can take is negative 1, and the largest value it can take is 1. So cosine of theta is always between negative 1 and 1. And the same is true for the sine of theta. Now coming back to here, our unit circle, with, as discussed, this length being cos theta and this length being sine theta, we know that tan theta is equal to the opposite divided by the adjacent. So applying this tells us that tan theta is sine theta over cos theta. So we've met two trigonometric identities here. We've met that cos squared theta plus sine squared theta is always identical to 1. And this one really ought to have an identical in as well. Tan theta is always sine theta divided by cos theta.